Welcome to class, ladies and gentlemen. Mr. Eicher here to teach you about random sampling methods. On this first page in your class notes, we will review some terms from a previous lesson. Terms such as convenient sample, non-response, voluntary response, response bias. And we'll also learn how to use a list of random numbers, a random number table, to select a simple random sample, SRS, simple random sample. And then we will talk about some other sampling methods, such as one called stratified random sampling. So, let's begin. Happy Friday, by the way. So we have parents are complaining about the amount of homework teachers assign over Labor Day weekend. This is very real world. Mr. Moen wants to investigate, as is his custom. So he plans on taking a sample of 8 teachers and record how much homework that teacher assigned over Labor Day weekend. Each teacher has been assigned a unique 2-digit number. So Mrs. Arnold, 00, C. Benatia, 01, and etc., etc. Yours truly, 05, close to my soccer number, 25. So, I would like you to answer questions A, B, C, D about those 4 terms. Make sure you understand what those terms are referring to. Explain what it looks like in this context. Context is very important on the AP Statistics exam. And also, as you're describing those, I'd like you to try to explain, maybe a little imaginative, creative thinking, try to explain the direction of the bias. Would we be overestimating or underestimating, possibly, the true amount of homework that's assigned over Labor Day weekend by teachers at this hallowed school? So pause this video, take, I don't know, maybe 10 minutes, maybe a little less, to answer these questions, and feel free to work with your neighbor. Pause this video. All right, a convenient sample. How might a convenient sample lead to a biased estimate? Now there's a variety of correct answers here, but a convenient sample would be Mr. Moen selecting the teachers who are easiest to reach. So, let's see. Maybe a convenient sample would be see how well I can write on this without a stylus. Ask the main hallway teachers. Oh, this isn't looking very good. Main hallway teachers. And now the main hallway teachers are what? History teachers and Spanish teachers, language teachers for the most part. Maybe some, anyway. So what could be a problem with Mr. Moen going out of his office, just going in that main hallway and asking like the 8 teachers in that area? Well, they're all the same subject, and maybe that subject assigns more homework than other subjects over the weekend. Maybe Spanish assigns multiple things to do over the weekend. Maybe history assigns lots of things to do over the weekend. So in that case, we could be overestimating the amount of homework that teachers assign, because we're specifically asking the teachers who assign a lot on the weekends. Now you could argue the other way. Maybe going to those main hallway teachers, maybe the history department, maybe the foreign language department, maybe they assign less homework on the weekends. Maybe they're kind, loving teachers, and they don't assign anything over Labor Day weekend, whereas the math teachers, tisk, tisk, maybe they assign way too much homework on the weekend. But they're kind of undercovered, right? Because he's not actually going to ask the math teachers. He's only going to ask the main hallway teachers. So this is just one example of many of a convenient sample, and I discussed why it might be an overestimate, and you could just as very well argue that it could be an underestimate. Sometimes it's clear from the context, but from this context, it's more creative thinking and imagining what could happen. You don't have to go both. You don't have to explain like why it would be over and under. You would just explain one or the other. Pick your choice and defend it with some reasoning. Next question, B, explain how non-response what that would look like. A non-response would be Mr. Moen selects a teacher to be part of his sample, but the teacher doesn't respond. So let's say Mr. Moen selected these teachers, Vansicle, Sheffield, Montgomery, McGaw, etc., etc. And what if some of these teachers didn't respond? And what if they didn't respond because they knew they would get in trouble? It's kind of an issue with non-response here. So teachers are selected, they're asked to participate, specifically they're part of the sample, but then they do not respond. Why might this be a problem? Well, maybe those teachers assigned way too much homework. In that case, if we're not going to include those teachers in our sample, then we're going to be underestimating the true amount of homework assigned over Labor Day. All those teachers who assign way too much, they don't want to participate, so that brings down the average homework load. All right, let's see what the next one is. Voluntary response. Be really careful the difference here. Non-response is that you were selected to be part of a sample and you're like, I don't want to participate, I'm not going to respond. Voluntary response is just a general call or a plea. Hey, do you want to be part of my sample? Come and answer this question. A lot of times samples are like this, or surveys are like this. So that would be like Mr. Moen sending just an email blast to these teachers. Hey teachers, email me back how much homework you assign over Labor Day because I want to see who assigns too much homework. That would also be another problem, but with the wording of the question. But let's say just the teachers who assigned very little homework responded. Then we would be underestimating how much homework we assign on the Labor Day weekend. If only teachers who know they won't be in trouble, if they're the only ones that respond, then we're going to underestimate how much homework there is assigned over that weekend. That's voluntary response. And then response bias. Describe one type of response bias in context. So the way that I worded the question last time would create a response bias. If Mr. Moen sent me an email saying, now tell me how much homework you assigned, and if I deem that it's too much homework, you're fired. That might be difficult to be entirely honest to Mr. Moen. So this is a response bias issue. Something about the way the question is worded, maybe how the question is presented by the interviewer, like interviewer bias. Who's asking the question? Is my response going to be anonymous? All those things can lead to response bias. I feel kind of obligated to answer in a certain way. So hopefully those terms were reviewed from you from our previous lesson. Definitely need to make sure you got that vocab down. In a previous lesson, we took a random sample with technology. That's how people would do it in the real world. But on the AP exam, they don't really want students taking random samples on their calculator because there's no way to tell what the right answer is because everybody got a different sample. So this set of random digits you would be provided on the AP exam, whether multiple choice or free response. And you need to know how to use these digits to select a sample. So above, I have assigned each teacher a 2-digit number. It has to be fair. Every teacher gets 2 digits. It wouldn't be really fair if these teachers over here, if we gave Mrs. Benatia the number 2, 2 occurs 10% of the time in numbers because there's 10 digits. But to give her 0, 2, now that's just as likely as something like 1, 8 occurring. There's like a 1 in 99 or 1 in 100 chance, something like that, that number would be pulled from the random number table. So here's how we use a random number table. So I've selected 2-digit numbers, and I read from left to right. And I'm going to, maybe I'll highlight this so you can keep track. I look at the first 2 digits and see, is 13 one of my teachers here? And it is. So Mrs. Lee would be part of my sample. That's my first person. I'm supposed to select size 8 teachers. The next number, 2-digit number, is this number, 87. That is not one of the teachers, so I'm going to skip that. The next number is 38. 38, it just missed, so that doesn't count. The next number is 15. 15 counts. Let's see, 15 is Mrs. Marry Me. She'll be part of my sample. 2 down, 6 to go. 98, that's no good. I'm just going to cross that out. 95, that's no good. I'm going to cross that out. 05. 05, that's a winner. Hey, I think it's rigged. The incredible Mr. Eicher. 29. Come on, there it is. 29, that is another good one. 292, Mr. Sherlock, Iron Man. And we got 09, that's a good one. 09, that was Mr. Goodman. And how many do we have? 1, 2, 3, 4, 5. Just a couple more. 08. Miss Gates, now Mrs. Vexler. Mrs. Gates is part of our sample. So that was 08. 73, we don't have any numbers that high, so skip that. 59, we don't have any numbers that high, skip that. 27. Highlight that. I think that's a good one. 27. Ah, the beloved Mr. Sheffield. You know, I'm going to change this to the right color because that was bothering me. Okay, 1, 2, 3, 4, 5, 6, 7. 7 teachers. And 41, that's no good. 86, that's all bad. 87, that's no good. 13. 13 should be a winner. But wait, that was Mrs. Lee. So do we want, as the question says, do we want a sample with replacement or without replacement? That means whenever a teacher is selected, do we replace them? Do we put them back in the pool of teachers that could be selected? Or do we not replace them? Once they're selected, they're out. They can't be picked again. What do you think? I hope you've decided. We should get 8 different teachers. So we don't want replacement. This is without replacement. So even though 13 could have been good, it was already selected. So we're going to then skip 13. Skipping 69, 57, 61, 54, 58, 08. 08. Oops. 08. I think we're skipping 08 because we already picked 08 above. That was Miss Gates. How about 15? Did 15, have we selected 15? Is that a new one? 15, 15, 15. Oh, yeah, we got 15. Running out of numbers here. 07. Oh, there it is. Mr. Ferreira. So we have 1, 2, 3, 4, 5, 6, 7, 8. Those are the 8 teachers that will be in our sample. So kind of stepping back, we got a couple math teachers. We got some electives, sports and such. We got a Spanish teacher in there. We got 2 English teachers, another elective teacher. So our random sample, ended up not giving us anyone in the science department or the history department, but we got math, foreign language, English, and some electives teachers. So that is how we use a random number table. And the back of the textbook has Table D as one of the last pages. Table D is where you can find, you might need to use that on your homework, a random digits table. Now the last question says, is it possible that by random chance our simple random sample selects, it is possible that by random chance our simple random sample selects a high percentage of teachers who teach freshmen and sophomores. What's the problem with this? How might we address this concern? How about pause this video and chat for a minute with your neighbor how you would answer those questions. So what's the problem? It is possible maybe not very likely since we did a random sample, but it is possible that we just happen to select more freshman and sophomore teachers. What's the problem with this? Well, as you know, junior and senior year students may have way more homework assigned. That's more likely they're in AP classes. So with an AP class, it's more likely that they're going to have more homework on the weekends. So what's the problem with this? If we pick the majority of freshmen and sophomores, maybe we would end up underestimating. We could end up underestimating how much homework is assigned on the weekend because these guys here are less likely to be in AP classes. Less likely AP. I'm not writing a lot because my handwriting is very sloppy. This doesn't mean that you shouldn't write a lot. Couple sentences. Don't do what I do. So we talked about the problem. How might we address this? Well, it would be really cool maybe if we could say, you know, let's make sure we get 2 freshman teachers in our sample, 2 sophomore teachers, 2 junior teachers, and 2 senior teachers in our sample. And then we might get a better, more accurate representation of the amount of homework that's assigned on the weekend. And that very idea, how might we address this question right here, will lead us to this next part of our lesson about methods that aren't simple random samples. So a simple random sample that we did up here, a simple random sample is when in this context, every possible group of 8 is equally likely. Equally likely. Every group of 8 is equally likely. So the 8 teachers that we chose, they're just as likely to be selected as some other different group of 8 teachers. That's a simple random sample. What we have on the next page other than simple random sampling, what sorts of other sampling techniques are there? Well, one that we're going to talk about today is called a stratified random sample, strat, if you could read my handwriting. Stratified random sampling. It is a form of random sampling. It's just a little different. Sampling. Next week we'll talk about what's called a random cluster sample. Cluster. And then there's a systematic sample. Systematic sample. Systematic sample is like ask every 10th person who walks in the door. It's systematic. Every 10th person. And then another one that's kind of a combination of all these that we don't talk about too much in this class, but it's interesting, is a multi-stage sample. So a multi-stage, you might set it up and do a stratified first and then maybe within a cluster. So sometimes that's like you pick a state in the United States and then from there you break it down to counties and then you break it down to neighborhoods and you kind of do maybe a different sampling technique, cluster, or stratified, or simple random sample at each stage as you go. And those are really common. We don't deal with those too much in this class. So let me explain this next activity that you'll do, and the point of the activity is to try to get you to understand how you do a stratified random sample and why we care what good is a stratified random sample. So let's look at that. Alright, the question says, suppose we wanted to estimate the yield of our cornfield. The yield as in how much corn a certain plot yields. The field is square, very convenient, divided into 16 equally sized plots. Now in reality there would probably be a way bigger field and way more plots, but let's just keep it simple for teaching purposes. Each plot has 4 rows and 4 columns, so you have the rows that, the rows that go this way. Oh, the rows that are down the side, these are rows, and then these are columns, like Greek architecture or any kind of architecture that has columns or vertical, hold the roof up kind of thing. And it says a river runs along the eastern edge, so we have a river there with some fish in it. So, using a random number generator, pick a simple random sample of 4 plots, place an X in the 4 plots that you choose. So, you're going to need a graphing calculator. You might need to pause this video as everyone hustles to get their graphing calculator out of their bag. Bravo to those students who were ready and able and willing and set. They had it on their desk, not playing calculator games, but, you know, learning. And some people might need to walk to the front and... Okay, is everyone ready now? Did you pause the video? Are you going to pause the video? Maybe you already paused the video. Okay, I'll stop talking about pausing the video. So, how do we do this? You're going to hit the Math button. Math is on the left side of the calculator. You're going to go over a couple with the right arrow until you get to PRB. And then you're going to select the one that says, what does it say? Random integer, randint, random integer. And you want a random integer from 1 to 16. And you want 4 of them. You're doing 4 numbers. Now, they should be different numbers. So if you happen to get a repeating number, then just get a new number to replace it. You know, actually, if you don't want to use your graphing calculator, you could, I'll allow you, if the sub is okay with this, to ask Siri, Siri, give me a random number from 1 to 16. And Siri should give you a random number from 1 to 16. Or whatever the equivalent to Siri is. Ask Alexa, maybe, if you have whatever Alexa goes to. I don't know. But anyway, you're going to do a random integer from 1 to 16. Let's say it outputs a 5. Then you'll select 5, or put an X on 5. Let's say then it outputs a 5. What? What am I going to do? Don't count that. Now it outputs a 3. I'll select a 3, and etc. Etc. meaning just have 4 circles, whichever 4 are random. And that's a simple random sample. If you want to take a peek at your neighbor's simple random sample, they will probably have different numbers. At least 3 out of 4, most of them, will be different numbers. That's a random sample. Let us move on. Now we'll select a stratified random sample. This is where it gets interesting. So now randomly choose 1 plot from each horizontal row. So you're going to pick one of these plots from 1 to 4. So on your calculator, you're going to do random integer again, randint, random integer. And you're just going to go 1, 4, and hit enter. And it's going to give you one number. Let's say it gave you a 4 that time, so that means you're going to pick this one. Now you're going to hit enter again, and maybe it would give you a 2 or something. That would be that one. And the next row, and then you hit it again, and let's say it gets 4, and that's okay. That repeat is okay, because this is a brand new row from this row we're on. So that would be this one. And then you hit enter one more time, and maybe it's a 1. Don't use these numbers. Make sure you're doing this randomly, because I'm not doing it randomly. I'm just picking numbers. I'm doing it haphazardly, which is different than randomly. So there you go. So that's what it should look like, something like that, as you're doing a stratified random sample. So a stratified sample, you're breaking up the population, in this case, into 4 groups. And then within each group, you're basically doing a simple random sample within the group. So that is a stratified random sample, stratifying by row. And then lastly, now if you need to pause this video to make sure you're doing this right, feel free to pause the video. Why don't you look at your neighbor to your left and to your right, see what kind of samples they have. You can quickly check if they got the right idea. If they have something like this, that would be a problem. You should only have 1 per row, not 2. No, not 2 per row. I'm very upset about that. Anyway, the last one we're going to do, finally, choose one plot from each vertical column. So one plot per column. Now we're looking this way, columns here, and we're going to do a random integer again, ranint, from 1 to 4. And let's say it outputs a 1. That 1 right there will be in my sample. And you're going to repeat that 4 times, 1 for each of those columns. So I would like you to pause this video after you've selected your stratified random sample by column. I'd like you to do 2 things. Number 1, I'd like you to check your neighbor's work, see what kind of samples they got, and see how their numbers should be different than yours. And number 2, I'd like you to answer the question, which method do you think will work best, and why do you think so? Pause this video. Now, when we say which will work best, remember what we're trying to do. We're trying to estimate the average yield for all 16 squares. We don't want to take the time and the energy and the money and the resources to go around to every single little square and check the yield. We would like just to do 4 of the 16 and use that sample statistic to estimate the unknown parameter, which is the true yield for the whole field. So let's turn the page, if you haven't noticed yet. Let's turn the page. On this page, the truth is revealed, and it will set you free. Now, it's time to harvest. And I noticed I should have an apostrophe there. Much better. The numbers shown to the right are the yield for each of the 16 plots. So notice the plots that are next to the river here, they had a better yield than the plots far away from the river, way over here. And, you know, that makes sense with water and all. So, what we get to do now is calculate. You'll definitely need a calculator here. You're going to calculate for each of your 3 samples. You're going to calculate the average yield. So, let me show you how this works. What I mean is, on your very first sample, let's say you got these particular, I wish I would have remembered which ones I circled. Let's say that that was your sample, 5, 10, 12, 16 in those positions. Whenever we go to that next page where the actual averages are, do not average 5, 10, 12, and 16. Those are just the numbers assigned to the fields. You need to average the ones down here, 5, 10, 12, 16. You need to take the ones that were in those positions. This one, I think, this one, and then these 2 were part of my sample. So you're going to do 7 plus 27 plus 148 plus 147, and you're going to average those. Whoosh, divide by 4. And you're going to do that for each of your samples above. So I really encourage you to work with your neighbor to make sure you're finding the right averages here. Whatever you're averaging should come from this table. Let's say your second sample, you were sampling by row. Let's say the rows that you selected were like these individuals from the rows. Those then you'll add together and find an average. So write those averages down. Once you and your neighbor have kind of agreed that you're doing this right, it's very important that you calculate these things right, you're going to go to here, average yield, and we have the simple random sample results. So you're going to take your number and you're going to come to the board. How about on the whiteboard to the right of the center board where it's projected? How about someone, either the substitute or a student, create these lines on the board. Make sure when you make them that you try to make the scale the same. And make sure that like 70 is like relative. You want them just the same scale. So volunteer to do that. That would be fantastic. And then if you could label them SRS, you could label that SRS. and then stratified by row, stratified by column. So what everyone in the class is going to do, you're going to come up and say, you know, on my simple random sample, my average was a 75. So 75 is, you know, right about here. Hopefully your dots are much better than my really messy squiggly marks. Stratified by row, let's say I was like over here. Stratified by column, let's say I was over here. And you're going to make a dot plot showing each of your results. And that's going to take some time, but that's okay. So pause this video, and once everyone has finished plotting all their points, copy down their graphs into your notes. So feel free to pause this video for quite a while everyone finishes. Thank you everyone for plotting your points on the board. I trust that you did that. And thank you for copying into your notes, at least roughly into your notes. I hope that you can tell some differences between these different samples. Now, since I'm not there, how am I going to do this? Well, let me show you what I thought I would do, and we'll see if it works out. Don't show you that yet. So I will direct your attention to this screen right here, that screen, and I direct your attention to kind of this area right here, the bottom of the screen there. See if I can maybe magnify it a little bit. So this is what we have. We have, for instance, when you did your simple random sample, you got perhaps 70.5. Perhaps you got 83.5. Perhaps you got 72.75. Those are simple random samples. Now, what I've done is I'm going to do 100 of them. There you go. Now in class, there's maybe 15 to 30 students in class, depending on what period you are. But there are my samples from my simple random sample. Maybe really similar to the ones you had. Here's what the graph looks like. There's my graph. Simple random sample. Samples, each dot is a sample mean coming from a sample of size 4. So notice sometimes we severely overestimated, well, we don't know if it's overestimated yet because I haven't told you what the reality is. Or maybe we severely underestimated, but in general it looks like right about here is the center of our distribution, maybe like at 70 to 75-ish. I guess we can always determine what is the actual yield for the whole field, and I think I could do that if I go like that. The actual is 70. 70 corn units. Cornies. Wheaties? Cornies? I don't know. Corny joke? Cornies? So that was that. And now if I stratify by column, you would get something like this. See if that works. So here's one that I got a 71 when I stratified by column, or 70, or 71.25, or 70, or 68.5, etc., etc. Let's do that 100 times. You did it in class 30. So there's 100 results. So, you know, if I had 100 students in class, that's what I would get. Maybe one day I'll have 100 students in class. But this is what that dot plot looks like. Where'd the dot plot go? Oh, there's the dot plot. Do you notice a difference, people? Now, the center for this dot plot, not a lot of variability. What's going on out here? Nothing. What's going on out here? Nothing. Everything. Look at that. That's right about at 70. Isn't that interesting? Did your dot plot look like that when you did it in class? Low variability. Low variability. I'm not going to try to spell it. Low variability. Low spread. Fascinating. Now, that's stratifying by column. If we were to stratify the other way, stratify by row, what would that look like? Well, I think I got this mic'd up. Stratify by row wasn't as accurate. That kind of looks like a simple random sample. That has a lot of variability. See, these sometimes we overestimated a lot, sometimes we underestimated. Now the center is at 70, and that's good. That's fantastic. That's where the center should be. That's where the parameter is. The reality is 70. But a lot of variability, high standard deviation, high range, high interquartile range. So what I would like you to do, I kind of hinted at this earlier, but I would like you to pause the video and chat with your neighbor. Why do you think stratifying by column worked to give us a good, accurate estimate of the parameter 70, whereas stratifying by row wasn't that helpful? And as you explain, see if you could give an example of the problem that you could face when you stratify by row. Try to explain an example of that problem. Pause the video. So here are all three. You have simple random sample. Notice the the average, or the center, might have been right about here, right around 70. Excuse me. The average here is right around 70. And the average here, the center of the distribution, is right around 70. They're all pretty good at getting at 70. However, these have way more of a chance of overestimating or underestimating what you'd like to estimate. Whereas this one is really beautiful. Everybody got really close to 70. So why is that? Well, I asked you to try to come up with an example to explain this. What could have happened, or what might have happened when you were stratifying by column? Well, since the river, we'll make it blue again, since the river and plots that were close to the river had higher yields, and plots that were far away from the river had lower yields, whenever you stratified by column, I see I made a slight mistake with my graph. We have simple random sample stratified by row in the middle now, stratified by column at the bottom. Sorry for the confusion there. So why did stratify by row, this middle one, why did it give high variability results compared to stratify by column, which didn't? So what is a stratified random sample? Stratified random sample, we take the whole population, we're going to divide it into groups. So here's group 1, 2, 3. And we divide it into groups, which makes it different than a simple random sample. Simple random sample, every possible group of 4 has the equally likely chance of being selected. Whereas in a stratified sample, since you're breaking it up into groups, taking some from each group, each possible group of 4 isn't equally likely of being selected. So just to put it this way, let's think of our school. If we broke our school into 9th graders over here, 10th graders, 11th and 12th graders, a stratified sample, let's say we take 2 from each grade, those are individual students there, to get 8 total students. A stratified random sample, we've divided the school into groups that are similar in some way, 9th grade, 10th grade, 11th grade, 12th grade, and we're taking a sum from each group. So when is it beneficial to use a stratified random sample, and what's the benefit? It's beneficial anytime you have subgroups in your population that you think might affect the response. So let's go back up here. If you think 12th grade students have more homework than 9th grade students, which is probably true, then it would be beneficial to stratify by grade, because 12th graders are going to be very different homework load than 9th graders, or 10th or 11th graders. Now we could separate our school into like guys and girls. Guy, girl. Uh-oh. GG. Guy, girl. But is there any reason why guys would be assigned more homework than girls, or vice versa? That might not be that strong of a predictor. So it might not benefit in that case, but it would benefit in this case where you have the different grades having different homework. So how do you choose a variable to stratify by? We pick the variable that is the best predictor of what you're trying to measure. That is, the variable that has the strongest association. So to summarize, in our field problem above, the columns were best because the distance the plot is from the river best predicted its yield. Or, in this situation, right here, stratifying by grade, grade would predict or be the strongest association with the amount of homework that a student had. So I hope seeing this video and selecting these different samples has illustrated the difference between a simple random sample and a stratified random sample. And I hope that seeing this picture that we had earlier, the one that I messed up at first, that picture, each of these sampling methods give accurate statistics with the center of each distribution. However, the last one, the bottom one, had the least variability in our statistic, and that's what we were going for. We'd like the statistic that is consistent and repeatedly over and over and over again, very consistent to the true mark. Thank you for watching this video. Have a wonderful day.